Hello everyone. Today I'm going to revise moment. What is meant by moment? Moment is a turning effect of a force. To understand this, let's imagine that we are looking at a door from top view, and this is the hinge, which means it is the axis or the point around which the door rotates. Okay, if we are trying to open this heavy door, we must apply force. So in what position should we apply this force? If we try to open the door and pushing or apply the force in the middle of the door here, so we apply large force to open this door. It is easier to us to apply the force in this position. So if we apply the force at large distance from the hinge, so it will be easier. So we apply small force. So if I have here F1 and here F2, so F2 will be smaller than F1. So once again, how can we calculate moment? Moment equal force times perpendicular distance. The unit of moment, Newton meter. So if we want to open this door easily, so we have to apply the greatest force at the farthest point from the hinge. Now, if we have a beam like this beam is centered on a pivot, and here is the shape of the pivot like this. At the center of the beam, so here, if we apply force in this direction, force F, so this beam should rotate in this direction. This is clockwise moment. So to return this beam to the balance again, we need to apply another force in this direction. So this force tends to rotate this beam in the opposite direction. So the applied moment here is anti-clockwise moment. So if the distance from this point to this point here, this distance is S1, and the distance from here to here is S2. So in equilibrium, the clockwise moment equal anti-clockwise moment. So if we have here the force F1 and the distance is S1, so the force should be applied here is F2, and so we have here F1 times S1 equal F2 times S2. I want to add something here. If we have the weight of this beam of 200 Newton, and this beam is focused or centered on the pivot, so the pivot apply a contact force of 200 Newton. Okay, so let's see some examples here. If we have a beam is pivoted on its center of mass, it is acted upon by two forces, 10 Newton and 5 Newtons, as you see here. Okay, what is the resultant moment about the pivot? Resultant moment means you have to calculate the clockwise moment and the anti-clockwise moment and get the difference between them. Okay, so we have this force push the beam in this direction, and this force pushing the beam to rotate in this direction. So this is clockwise moment, and this is anti-clockwise moment. So the clockwise moment here equal 10 times this is the force, and here the distance is, if this total distance is 25 and this is 15, so this distance is 10 centimeter. So we have here 10 times 10 equal 100 Newton centimeter. Okay, and anti-clockwise moment equal 5 times 15. This means equals 75 Newton centimeter. So these two moments are opposite in direction. So the biggest one is 100 Newton, which is in the clockwise direction. So the resultant moment equals 100 minus 75. We get 25 Newton centimeter in the direction of clockwise. So the answer here is C. Another example. A beam of weight 60 Newton is suspended from two strings B and Q. String B is 30 centimeters from the left hand end of the beam as shown, and string Q is not shown. So the tension at B is 2 Newton. What is the tension in string Q and where it is attached so the beam is in equilibrium? Let's look at the tension in string Q. So we have to add a string here, Q. We don't know where exactly the position of Q. And what is the tension of this Q? Here we should know that this beam is weight 6 Newton. And we have string apply upward force of 2 Newton. So we need another string to carry the beam with 4 Newton. Okay, now where we can apply this 4 Newton, in what position? We have here, this is the clockwise moment. Clockwise moment equal 4 times distance from the center of mass equal to the applied force in the other side times the distance from the center of mass. And this distance, since this total distance is 30, so this one is 10 centimeter. So we have here 10 centimeter. So we have here distance is 2 times 10 divided 4. We get 5 centimeter away from the center of mass. So the position of Q should be 5 centimeter away from the center of mass. So we remove this here from here and we apply this force here. So it is a distance. Here this distance is 5 centimeter. Here look at the answer. Here 4 Newton and 10 centimeter from the left hand side. 4 Newton is correct. And no, it is not 10 centimeter because this distance is 20 and here is 5. So this distance must be 15. So the correct answer is 4 Newton and 15 centimeter from the left side. In this example, the diagram shows a 3 meter uniform beam, AB, pivoted 1 meter from the end A. The weight of the beam is 200 Newton. Okay? Here the weight of the beam is 200 Newton. This is very important information. We here look for the center of mass of the beam and we apply here this force of 200 Newton. Okay, the center of mass. And the length of the whole beam is 3 meter. So this center of mass at distance 1.5 meter from both ends. Okay, with the question here, copy the diagram and mark the beam center of mass. So here's the center of mass. This is okay. Add a row to show the following forces. The weight of the beam. This is the weight of the beam. This force. The contact force on the beam at the pivot. So the contact force must be here. It's applied by the pivot, so the contact force will be upward here, and it equal to the downward force, which is the width equal to 200 Newton. A third force F presses down the beam at point A. What is the value of force is needed to balance the beam? So what is the value of this force here? Here the answer of part C, because here is a pivot, so we have F times the distance, which is 1, equal to 200, and this distance is 0.5, because this is 1.5 and this is 2, so we have here 200 Newton times 0.5. Okay, so the force here equals to 200 Newton times 0.5 divided 1 equal 100 Newton. In the beginning, the contact force of B was 200 Newton, but now we add another force to be 100. So the contact force in this case will be, this is 100 Newton plus the 200 Newton. So the contact force is 300 Newton. Thank you for watching. See you next video.